Hi, folks. Welcome back. It is now section 6.3, and this is about drawing similar figures. But once again, as always, we're going to start with a very quick review of what we learned in 6.2. In this case, determining if two figures are similar. Feel free to pause the video, work it through for yourself, and then watch it to make sure that you've got the concepts. You've got a photograph enlarged to poster size. The original photo is 5 inches by 7 inches. If it's enlarged to 130 by 189, will the poster be similar in shape to the original? So remember, similar polygons have all their angles that are the same, and it doesn't say for sure, but almost all posters I've ever seen are proper rectangles as our photos, right? So we know that the angles are all going to be 90-degree angles. We don't have to worry so much about that. But what we want to do is make sure that our original poster or our original photo, which is 5 by 7, can be scaled up into a larger poster, which is 130 by 189. And so we want to check to see if these scale factors are the same. So to go from 7 to 130, we're going to do 130 divided by 7. That's the model to the original. And 130 divided by 7, that doesn't work out nicely. So let's actually take a look at it as a ratio or as a decimal. 130 divided by 7 is 18.57. 571428, etc. And then in our second, that shouldn't be 130 over 7. I'm looking at the wrong one. 130 to 5. We're going to compare similar sides, right? 130 and 5. My apologies. 130 over 5. That one's a lot easier mathematically. That's going to be 20 plus another 6. 26 to 1. Right? If we reduce it, 130 divided by 5 is 26. Now, the question is, 189 over 7, is this also going to be equal to 26? I can tell you right now it's not, because an odd number divided by an odd number is never going to give you an even number. Neither one of them has a factor of 2. So 189 divided by 7, we're going to do this just to be sure. It has a scale factor of 27. No, they're not going to be the same size. I lost you from my screen. I want to make sure it's still there. Okay, so let us continue with the lesson for today, drawing, which I really love this part of math. You get to take stuff out, get to draw fun stuff, use some grid paper here and there. So we're asked to draw a figure that's similar to the one given with sides that are 1.5 times the length of the original. Graph paper is great for doing this. Some of you may have done art classes where you use a grid to enlarge something. So this is where we can do that. The same concept kind of applies. But usually when you do the grid to enlarge something, you use larger squares. In this case, we're just going to use more squares. So 1.5 times the length of the original. If we've got 1, 2, 3, 4, 5, 6 squares for this left-hand line here in the original, 1.5 times as much, 6 times 1.5, that's going to be 9. So we're going to start same place. We're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have this line here. Okay. And so this is 9 high on this one. The bottom is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 long. times 1.5 equals 27. So we're going to have to count off 27 along the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So it's going to end here. And I'm sure you guys will all use a straight edge to do this. Great. I find it easiest to always count on straight lines because, well, they just kind of are easier. I guess you could count the diagonals because these all pass through the diagonal. So they go directly through there. So the same angle will take us at that 45-degree angle and go through all diagonals in the new square. And this is 4 diagonals long. So it's going to end up being 4 times 1.5 equals 6. So we're going to count 1, 2, 3, 4, 5, 6 diagonals and connect them. And then we have, again, 4 times 1.5 is 6 across. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Takes us to there. And we just have one more line to fill in. It also goes across the diagonals, but even if it didn't, because what we've done has all been counted carefully, we know that this connection would have to be the same because the rest of it is all similar. So with your straight edge, you'll make sure not to go too far. Okay, erase that. Okay, and careful, I accidentally erased one too many. So now let's actually get them to connect. That's better. That's still probably a little bit better. But you see what I'm saying. Okay, it's really hard without a straight edge to do this. Make sure you use a ruler or some sort of straight edge. Okay, next question. When you're actually building a scale or a model from original, how do you do it? Xavier's building a staircase using scale drawings. On the drawing, the height of one stair is 0.5 centimeters. The depth is 0.9 centimeters. So height and depth. So height is 0.5, depth is 0.9, and those are centimeters. So when you actually build these, if we've got a scale factor of 40, now remember I said quickly in the first lesson of this chapter, scale factor is what you multiply or divide by in order to figure out your actual size or your scale size. So if we are going to take this model staircase, so the miniature one, the school for really tiny people, or really good looking people, but how are they going to fit inside? We're going to do either multiply it by 40 centimeters or divide it by 40 centimeters. What's going to make more sense for stairs? Are we going to get smaller than 0.5 centimeters or bigger? 0.5 centimeters is about that big. Obviously, that's not going to be a real stair. Okay, so we're going to multiply by 40. We take 0.5 centimeters, multiply it by our scale factor of 40, and our height is going to be 20 centimeters. Similarly, we take 0.9 centimeters times 40. Like, okay, I used the word similarly there because we're talking about similar figures. Just a little bit of a math joke. 0.9 centimeters times 40 is going to be 38 centimeters in depth. That's the height and depth of each stair in his staircase. And of course, the whole staircase will be much larger than just one stair. It might be grand and ornate like that. Look at that beautiful wood paneling. It's like 50s wood paneling, elaborate, fancy. I don't know, you don't see houses like that anymore. Too expensive. And I believe that's it. That's it for lesson 6.3. Pretty simple. I don't know how I'm going to test you on the drawing side of things in the quiz, but we'll see. You should be able to do it. It's a great, useful skill to have. It's kind of fun to do at the same time. So try to make sure you do the workbook questions associated with this. All right, and I'll see you for 6. 0.4.